Hello everyone, welcome to my channel techtejendra. We are now at the part 6 of our containers and the Kubernetes tutorial series. In this tutorial, we will learn how to create container images and the concept of Dockerfile. Okay, so let me go ahead. So what is Dockerfile? Okay, and how to create our images. So to create our images is by using the Dockerfile. Okay, it is kind of configuration you can say, or you can say the commands. Okay, to create your own container image. Okay, so it is an example here. So here we are using a base image. Okay, the Dockerfile structure, and these are the keywords of the Dockerfile. Okay, from maintainer, label. These are some commands: run, expose, entry point. Okay, so let me give you some brief idea about it. So from means to create a container, it is not kind of that you will do something from scratch. Okay, you must need a base image for your container. Okay, base image can be a operating system, maybe the Ubuntu base image, maybe the Red Hat Linux base image. Okay, kind of. And then top of it might not be the bare operating system. You can also use the base image, kind of MySQL base image. Okay, so top of the MySQL base image. Now if you want to customize something more into the MySQL base image, then you can create your own image over and top of this MySQL base image. Okay, kind of Java base image, Python base image. Okay, if you want some more either customization. Suppose you are having a web service or a microservice running over the Python. Okay, so here what you will use from Python base image. Okay, base image you can find from the registry, as I have shown you in our previous videos. Either you can use Docker Hub, you can use the query.io. Okay, so you will find your base image from here. For an example, for Python, if you are having your microservice, so Python as a base image, and then your application code will run on this Python base image. Okay, and then Python is also is having the more deeper layers of other base images, like, so maybe your Python base image might be running on the Red Hat Linux, might be running on the Ubuntu. Okay, so these image might be having the base image like UBI 7 is the Red Hat Linux base image. Okay, so its name is UBI, Universal Base Image for Red Hat Linux. Okay, so so let me come back to our example. So if you are having your Python, then over your Python base image, then you will having your code. Okay, your code which will run on the Python. So whatever the configuration file you are having, whatever the code executables you are having, you will copy this code, these executables, configurations files, properties file in a specified directory to be run in the Python base image. Okay, once you will copy, then you will expose them, and then you will learn. Okay, so let me give you some briefly ideas. So from, I just tell you, it is the base image. Then maintainer, it is kind of a document purpose, that who is the maintainer of this container. Okay, who is the owner of the container. And then label means some description about the about the container. Okay, so like here we are saying description, a basic Apache container on RHEL7 UBI. Okay, as I told you, this UBI is the for RHEL, Red Hat Linux Enterprise. Okay, then this is the commands. Okay, run yum install httpd yum clean all. Okay, so what it is doing, run means once you have load base image, then inside the base image it will execute these yum command. Okay, so inside the container, now you are creating your container. So at the time of creating the container, first it will load this UBI base image, and then will execute this yum command inside the container. Okay, and this yum command will install HTTP server. Okay, and also let me tell you, everything here, every line in a Docker file is a layer. Okay, so over the base image, then it is the layer 1, layer 2, layer 3, layer 4. Okay, that's why we are not using here two run command. Okay, we are combining yum in a single run command. Okay, The other way around is we can create this one install instruction in one run command, another in another run command. Okay, but we are not doing it because it is a bad practice, because it is every single line in a Docker file is a layer. Okay, that's why we need to minimize the layer. Okay, that's why we combine both the yum command in a run single command. Okay, then we are having run echo hello. Okay, so what it is doing, it is hello from Docker file. Okay, it is the content, it is placing where into this directory inside your container. Okay, and expose 80 means, the expose means the listening. Okay, container now will be, once we are doing, once we are using expose 80 means now container is listening at the port number 80. Entry point, this is the most important thing. Okay, till from to expose, from here to here. Okay, we are creating our container. Okay, now we are creating the image, you can say, or you can say from image we will create the container, right? So from here to this we are creating image. Okay, and once image is there, we will save it into the push back into the registry or the local storage. And entry point means once we do this run command, okay, sudo docker run or sudo podman run, at the time this is we have already created, this will execute at the time of run. Okay, means at the time of entry point, now the httpd command, it will execute at the time of once we will provide sudo docker run. Okay, so this entry point will execute, then your container would be available and will be in listening mode at the port 80. Okay, so let's do it by example. So let me show you. Okay, okay, so for a demonstration, okay, for example purpose, this is my application. This application I have written in Java. Okay, it is a Spring Boot application and using the maven. Okay, so you can see here it is my pom.xml file. If you are not much aware about the Java, then not an issue. I am just showing this example to give you good idea about the Docker file and how to create the container. I am not going into deep of the Java and Maven and other things. Okay, my focus is to just give you the idea of the Docker file, not creating the container concept, not about the Java and every Spring Boot. Okay, so it is having the pom.xml file, and then here is my source code. Okay, so let me use, this is my git account. Okay, and let me clone this code into our machine first, and then from here we will create our container and we'll run and execute our this Java application, Spring Boot application inside the container. Okay, so let me copy this URL and I am going to my machine here. This is my Red Hat Linux machine. Podman is already installed here. Okay, so currently my directory is empty. So let me first get clone. Okay, so cloning is done. Okay, our code has been come. So let's change the directory. Okay, let me show you the tree command here. Okay, so this is our structure of file. Okay, so let me maximize it. Okay, so from here it is starting. Okay, so the source file and inside source file, this is our code. Okay, and I have written all the commands. Okay, so one by one, let me execute all the commands. Okay, so first thing we need to create our Docker file first. Okay, so let me create our Docker file using vi docker file. Okay, so by default docker file name is the docker file itself only. Okay, but as you can see in my this directory here, we have already having one docker file. Okay, so that's why this actually this code I have written for some other purpose, and it is having its own docker file. So let's not change it. Okay, let we create our own docker file with the name docker file. underscore t. Okay, so it is our new Docker file. Let me create it. Let me copy all the command, and I will explain you every line here. Okay, so this is our Docker file starting from here. Okay, so from okay, maven 3.5 jdk alpine as build. Okay, what is the meaning of this line? Okay, so our base image is maven. Okay, so we are starting creating our image, and we are using base image maven. Okay, it will get all the image from the Docker hub. Okay, because we are not specifying anything here, so by default it will get from the Docker hub. There are some configurations. Okay, I'm not going there. Okay, if you want to choose from which registry it should use, okay, by default it is Docker hub. That's why it will get this image from Docker hub. And we are now giving this image name as build. Okay, maintainer is my name. It is I am the owner of this image. Then copy. Okay, what we are doing here, copying source inside. Okay, copy means copy from your host machine to the container. Okay, so copy command, what is doing, it is copying the source directory from my host machine to the containers home app source directory. Okay, and same way copying pom.xml file into the home app. Okay, likewise if you are having your own code or many configurations file, property file, you can copy from your host machines where your code is there, like we did our cloning from the git. So our code is in our host machine, then now we are copying it into the um, container. Okay, wherever we want to copy it. Okay, so we choose this directory to copy our code. Then we are giving the run command. It is a kind of shell script, or you can see the shell command it is going to run. Okay, so what is going to run, it is a kind of command, and this command will be run inside the container. Okay, so command is maven. Okay, it is having maven build. So maven, our file name is home app pom.xml, and then it will clean at the package. Okay, so what would be the output of once of this maven command, it will be a jar file, executable jar file. Okay, now let come in. So from this point to this point, sorry about that. Okay, so from this point to this point, it will create a temporary, or you can say the intermittent container. Okay, it is not having from here to here, it is not having entry point. Okay, it is kind of an intermittent container which will be used for creating another container. From here we are creating another container. Okay, container image. So this container image is using Java. Okay, openjdk 8 version, and copy from build. Okay, so it was our intermittent container this till this command. Okay, till run command. Now the output of would be the jar file. Okay, so now we will use this container to create another container image, and copying from build. Okay, the name of this container is build, so we are copying build. Okay, from build, our jar file will be created inside this directory. Okay, inside home app target, and this is our jar file name. Okay, so it will first copy from this container to now the parent to the actual container, then expose 80. So now this container will be um, listening out on 8082 port. Entry point, as I told you, once we will execute the container, run the container by our sudo podman run command. Okay, so it will going to execute these command. Okay, Java -jar, and it will execute this jar file. That's all. Okay, very simple and small Docker file. Okay, so let me also show you in the code expose 8080. So my this Spring Boot application, if I go inside my Spring Boot application, inside the source, okay, resources YAML file, you can see. Okay, my application is running on 8082 port. Okay, That's why we expose this port here. Okay, let we come out, save it, and come out of our editor. So now our Docker file we have created. Okay, this is our newly created Docker file. Now what we need to do, we need to create our image. Okay, so for creating our image, what we will do, this is our command. Okay, to create. So we are having podman. So let me first, let me see what all images we are having. So currently we are having that much of images in our podman. Okay, now let me create our new image here. So, oh, sorry, what happened? Sorry, some other thing was there. Okay, so let me copy this command and let me paste it. Okay, so sudo podman build. Okay, build is the command. So now it will build the image. Okay, -f is the file name. So docker file underscore t hyphen t is the your image name. Okay, so it will be the image name h2 movie info service, and then dot means in the present directory. Okay, so let me start. Okay, so now you can see step 1, step 2, so everything is a layer here. Okay, so it is getting all these file, okay, all these things, and then from it started the maven build. Okay, so it will take some time. Okay, so let me go by okay, it will take some time, so let me give you some brief idea about what this application will do. So let me go inside the source code of this Java microservice. Okay, so inside source, this is our main file. Okay, and here you can see this is the entry point. Okay, REST controller, and entry point is slash movies. Okay, is the entry point, and inside it we need to provide a movie ID. And once movie ID is there, it will return a JSON object. Okay, a JSON object with the movie ID and the movie name. Okay, so it is calling a movie object which will return movie ID and the movie name. Okay, so very simple, very simple web service it is. Okay, so by calling this entry point, it will just return a JSON value. That's all. Okay, so let me see here. Our maven build is still going on. It will take some time. Okay, it will getting all the dependencies for maven. Okay, and then it will first compile the code. Okay, and then we'll create the jar file. So the thing is going on. Let's wait for a moment. Okay, you can see it is the Spring Boot application, as I told you. So everything, whatever it is going on currently on his screen, it is basically creating a container, or you can say the image. So everything is running inside a container. Okay, not in actual host machine. It is inside a container. Whatever you are currently seeing the moving part of screen. Okay, so our build is success. Build is success. Okay, now we are at step 9. Okay, now here, okay, from so first container is completed. From here, another image creation has been started. So intermediate step has been finished. Okay, and all the steps has been finished now. So let me see whether our image has been created or not. Okay, so let me see. Yes, you can see here our new image has been created here. Okay, we can push this image in any type of registry if you want, like in a public or in a private mode. Then this none. Okay, this is the intermediate container which I was talking about. Okay, so it's created two images. One is the with ID none. Okay, because it was the intermediate. By using this intermediate, we created this actual one. Okay, so now let we run this image. Okay, so this command we are going to use to run our image. I will tell you what it will do. Okay, sudo podman run. Okay, run, then -d means in background, name would be s2, and port would be 8082 and 8082. So as you know that our container is listening on the 8082 port. Okay, so same way in our host machine we are assigning 8082 port. Okay, host machines also you can assign any port, but let for easy purpose let we assign 808. Okay, then this is our image name. Okay, so let me run it. Okay, our podman is in running state now. Okay, so 9 seconds ago. Okay, so our podman is in up and run state. Okay, so now let we try whether our application is accessible or not. So let we use curl. Okay, curl or localhost and 8082 is our port. Okay, and entry point is movies and movie ID. Let we give it 4. It should return a JSON object to us. Yes. Okay, so it is returning a JSON object to us. Okay, with this simple information, movie ID 4, name of movie Hatya. Okay, so that's all. Image has been created, and you can push your this image into any registry for the further use. Okay, so that's all for this tutorial. And guys, this was the last um, tutorial in the perspective of containers. Okay, from next video we will start talking about the Kubernetes and the OpenShift. Okay, we will first start with the Kubernetes and OpenShift architecture, and then we will learn the concept of Kubernetes and OpenShift. If anyone is having any doubt about the containers, because understanding of the container is must before moving to the Kubernetes part. Okay, so if anybody is having any doubt, go back to my previous videos, learn containers first, do the practice of these containers. Okay, and then from next video, I will teach you about the Kubernetes and a little bit of OpenShift. Okay, because for exam EX-180, exam is all about containers and the Kubernetes. But yes, OpenShift is also very important. Okay, so thanks everyone for watching this video.